Hey everyone, my name's Trevor, and in this video we're going to create a save and load system in Unity that can be applied to any type of game. As an example, we'll be saving and loading a few things from this simple platformer game. We'll save and load the amount of times that the player has died, the player's position in the scene, and finally the specific coins that they've collected. We'll be saving the data to a file in both a readable JSON format as well as an encrypted format, which we'll be able to toggle between in the Unity inspector. And of course, the code for everything that we're going to do can be found on GitHub, which I'll put a link to in the description of this video. How this is going to work is that we'll create a simple C# class to store the state of our game's data. Then we'll create a singleton class called the Data Persistence Manager, which will keep track of the current state of our game data, as well as be responsible for orchestrating all of the logic that goes into actually saving and loading the game. To do so, we'll create an interface called iDataPersistence and have any other script in our project that needs to save and load data implement that interface. When the Data Persistence Manager starts up, it'll gather and store references to any script that implements that interface, so we can call those scripts appropriately when we save and load the game. The next step we need to take is actually persisting that data somewhere outside of the game, and in our case that's going to be to a file. We'll create a file data handler class that's going to be managed by our Data Persistence Manager, and it'll be responsible for converting our game data C# object into a more compressed format and then writing that information to a file. This format can be binary, XML, JSON, plain text, or really anything, but for this tutorial we'll be going with a JSON format. And of course, the file data handler will also be responsible for reading that file and converting the JSON data back into our game data C# object. The process of going from a C# object to a more compressed format is called serialization, and the reverse of that is called deserialization. You'll hear those terms at least a few more times throughout this tutorial. And last, as a final touch, we'll add the option to encrypt the JSON data so that it isn't as easily changeable by the player. And just to note, the main advantage to having the data handler somewhat separated out like this is that if we ever want to change our method of storage, for example, maybe we need to save to the cloud instead of to a file, we just need to write a different data handler and then the rest of our system is mostly unaffected. So just to cement how this is going to work, let's run through a quick example. When we first start the game, there won't be any saved data to load. In that case, we'll want to start a new game, which is really simple in this system as we'll just need to create a new game data object. From there, whenever we want to save the game, the Data Persistence Manager will pass that game data object by reference to each script that implements the iDataPersistence interface. Those scripts can then modify the game data object, and after all the scripts have done so, the Data Persistence Manager will use the file data handler to convert the game data to JSON and then write that data to a file. Then when we go to load data, the Data Persistence Manager will use the file data handler to read in the serialized data and convert it from JSON back into the C# game data object. And after that, the Data Persistence Manager will again pass that data to any script that implements the iDataPersistence interface, so those scripts can initialize whatever they need to from that saved data. And that's how it's going to work. Now, with all of that said, let's get into actually implementing this. We'll start with creating our game data for the things that we want to save. Like I mentioned previously, we're going to save the amount of times that the player has died, the player's position, and these specific coins that they've collected. We're going to start off simple though and only save the player's death count just so we can get the initial system working. In the scripts directory of the project, we'll create a new folder called Data Persistence where we'll put all of the scripts relating to this save and load system. In there, just to keep organized, we'll create a new folder called Data, and then in there we'll create a new C# script called Game Data and then double click it to open it up. We can remove these placeholder start and update methods along with mono behavior. We'll also need to add system.serializable right above the class definition. Then we'll create a public int called death count to store the amount of times that the player has died. Next, we'll create a public constructor, and in that constructor, we'll initialize death count to be 0. The idea here is that when we start a new game, whatever we define in this constructor will be our initial values to start with. Next, we'll create the Data Persistence Manager script. Back in Unity, under the scripts Data Persistence folder, we'll create a new C# script called Data Persistence Manager and then double click it to open it up. This is going to be a singleton class, meaning that we only want one of them in our scene, so let's set that up. We'll create a public static data persistence manager instance, and then this syntax here just means that we'll be able to get the instance publicly, however we'll only be able to modify the instance privately within this class. Then in the awake method, we'll initialize our instance, and if there already is a data persistence manager in the scene, we'll throw an error to let ourselves know that something went wrong, since by design there should only be one of these in the scene at any given time. So as I mentioned previously, this class is going to keep track of the current state of our game's data, so we'll add a private game data variable called game data. The core of the data persistence manager is going to have three public methods: new game, load game, and save game. New game is going to be really simple. We just need to initialize our game data to be a new game data object. Load game will be a bit more complicated. First, we'll want to load any saved data using the file data handler, but we haven't created that yet, so we'll just add a to-do comment for now. Second, if there was no data to load, we'll want to initialize to a new game. We can do this by checking if our game data is null, and if it is, we'll add some logging to let ourselves know that we're initializing to default values, and then we can just call our new game method. And third, we'll want to push that loaded data to all other scripts that need it, but we haven't set that up yet, so we'll just add a to-do comment for that as well. And last, for save game, we'll first want to pass the data to other scripts so they can update it, and second, we'll save that data to a file using the file data handler. For now, we'll just add to-do comments for both of these things. As for when these methods are called, it depends on how you want to load and save your game. This class is set up as a singleton instance, and these methods are public so that they can be called from other scripts. For example, from a main menu, a pause menu, or really anywhere else that you need to save and load data from. With that said, for this tutorial, we're going to keep things simple. We'll load the game on startup and then save the game when the application exits. To do so, we'll create a start method and then call load game from there so that the game is loaded on startup. And then we'll also create a method called onApplicationQuit, which gets called anytime the game exits, and then we'll call save game from there. The next step we'll take is setting up the system to call other scripts when we save and load the game. Back in Unity, we'll create a new C# script called iDataPersistence and double-click it to open it up. This is going to be an interface, or in other words, it's just going to be used to describe the methods that the implementing script needs to have. We can remove these placeholder methods, remove mono behavior, and instead of this being a class, we'll change it to be an interface. Then we'll declare a method called loadData that takes in a gameData object called data, and another method called saveData that takes in a reference to a gameData object called data. The reason we want to pass by reference here is that when we save data, we actually want to allow the implementing script to modify the data, whereas when we load data, the implementing script only cares about reading that data. In this sample project, I have a script that's attached to the UI text called deathCountText, which is also where I'm keeping track of how many times the player has died. If we take a quick look through the script, we'll see that there's a death count variable at the top that we're incrementing every time the player dies, and then we're updating the actual UI text in an update method to whatever the value of that variable is. To allow this script to save and load data, we'll implement the iDataPersistence interface by adding it after mono behavior at the top of this script. Then we'll add the methods our interface defines, load data, and save data. When we load data, we'll just set the death count in this class to the death count in our game data. In the save data method, we'll do the opposite and modify our game data death count by setting it equal to the death count in this class. Back in the data persistence manager script, we need to write some code to get a reference to every script in our scene that implements the iDataPersistence interface, and then call them appropriately in the save game and load game methods. At the very top of this script, we'll add a using statement for system.link, which is going to give us some nicer syntax for finding the iDataPersistence objects. Then we'll create a new list of type iDataPersistence called DataPersistence In our start method above the load game call, we'll say this.dataPersistence equals find all dataPersistence, which is a method that we're going to create. Towards the bottom of this script, we'll create a private method that returns a list of type iDataPersistence called findAllDataPersistence. Because we're using system.link, we can find all scripts that implement the iDataPersistence interface in our scene using this line of code here, but just keep in mind that those scripts also need to extend from mono behavior to be found in this way. Then we can return a new list and pass in the result of that call to initialize the list. Now in the load game method, we'll loop through each of the data persistence objects in our list and then call load data, passing them the game data. Likewise, in save game, we'll do the same thing, but call save data and then pass the game data by reference. And just for now, we'll also add some logging statements to print out the death count when we load and save, just to make sure this is working so far. Back in Unity, let's set this up and make sure things are working as expected. In the scene hierarchy, we'll create a new game object called Data Persistence Manager, and then we'll drag on the Data Persistence Manager script to add it. After that, we can hit play to enter play mode. If we take a look at the console logging, we'll see that no data was found and the death count was initialized to 0, which is correct according to how we have everything set up. If we die a few times, so our death count is 3, and then we close the game, we'll see that upon exiting the game, we get some logging indicating that our death count is 3, which is also correct. Of course, if we try to play this again right now, the death count will be initialized to 0 again because we're not storing the data to a file yet. So let's do that next. In Unity, we'll create a new C# script called File Data Handler and then double-click it to open it up. We can remove these placeholder methods as well as mono behavior since we want our Data Persistence Manager to be the one managing this. We'll also add using statements for system and system.io. Then we'll create a couple of private string variables, one called data_dir path, which is going to be the directory path of where we want to save the data on our computer, and another called data file name, which will be the name of the file that we want to save to. We can then create a public constructor to take in these two values and set them accordingly. We'll then create a public method called load, which will return a game data object, and another public method called save, which will take in a game data object. We'll implement the save method first. To save data, we'll first need a full path which includes the file name. We could use string concatenation like so to create this, but since different operating systems have different file separators, a better way to do this is to use path.combine, passing in the directory path and the file name to combine the two. Then we'll do a try-catch block here, so that way if an error occurs when we're writing data to the file, we can catch that and then log an error to let ourselves know what happened. Before we do anything else, we should create the directory path just in case it doesn't exist yet on our computer. We can do this with the line directory.createDirectory and then pass in the directory path that we want to create. You could just use the data_dir path variable, but another way to do this since we're dealing with a full path at this point is to say path.getDirectoryName and then pass in the full path to that. Next, we want to serialize our game data object into a JSON string. We'll create a new string called data_to_store and then set that equal to JSON_utility.toJSON and then pass in our data. Optionally, we can format the JSON data by passing in true as an optional second parameter, so we'll do that as well. And finally, we'll actually write the file to our file system. The syntax for this can be a little strange, but when dealing with reading or writing to a file, it's best to use using blocks, as they ensure that the connection to that file is closed once we're done reading or writing to it. So we'll say using, and then we'll create a new file stream, passing in the full path and then specifying file mode.create since we want to write to a file. Then inside of that using block, we'll do another using statement and create a stream writer, passing in the stream that we just created. And then finally, we can do writer.write and then pass in the data that we want to write to that file. That's good for the save method, but now let's fill out the load method, which is going to read that file and then parse it back into our game data object. Just like with the save method, we'll want to work with a full path that includes the file name, so we'll copy and paste that part over. Then we'll declare a game data object called loaded data, which is the variable that we're going to load into. Before we try to load data, we should check if the file we're going to load from actually exists. Then we'll return our loaded data at the bottom of this method, meaning that if the data exists, we'll load it, but if it doesn't exist, we'll just be returning null. And before we actually try to read from the file, we'll do a try-catch block just like we did in the save method. For reading in the file, we'll declare a string called data_to_load. Then we'll add a using statement and create a file stream, passing in the full path and then specifying file mode.open since we want to read from the file. And then another using statement where we'll create a stream reader and then pass in the stream that we just created. And finally, we can use reader.readToEnd to load the file's text into the data_to_load variable as a string. So that will load the serialized data, but now we need to deserialize it from JSON back into our game data object. We can do this by calling JSON utility.fromJSON, specifying the game data type, passing in the serialized data, and then setting the result of that to our loaded data variable. And that'll do for the load method. So now let's hook all of this up. At the top of the Data Persistence Manager script, we'll add a serialize field variable for the file name that we want to save our data to. We'll also declare a file data handler variable called data handler. Then in the start method, we'll set the data handler to be a new file data handler and then pass in application.persistentDataPath for the directory, and then the file name variable for the file name. Application.persistentDataPath will give the operating system standard directory for persisting data in a Unity project. If you want to save your data somewhere else on your machine, you can change this, but unless you have a good reason to, then sticking with application.persistentDataPath is usually a good choice. I'll put a link in the description of this video to the Unity documentation that you can use to see where this points for your operating system. At the top of load game in the Data Persistence Manager, we'll set our game data equal to datahandler.load. And take note that when the save data doesn't exist, the result of this method will be null, in which case, with how this is currently set up, we'll create a new game. Then at the bottom of the save game method, we'll call datahandler.save and then pass in the game data to be saved. And we can also remove these log statements, since at this point we should actually see the data persist to a file. Back in Unity, in the inspector for the Data Persistence Manager script, we'll need to pick a file name to save to. This can be whatever you want and have whatever file extension you want, or no file extension if you prefer. Since we're saving the data as JSON, you could give it a .json extension, however I'm going to call mine data.game. Now if we enter play mode, you'll see that our death count starts at 0, so we'll die a few times and then exit play mode so the game saves. Now if we go to where the application.persistentDataPath is for your operating system, you should see a file with the name you specified. We can open this up in a text editor to see that our data was saved to this file in a JSON format successfully. And back in Unity, if we go back into play mode, our death count now initializes as the loaded value. This shows that the core of our save and load system is working as intended. Next, let's also store the player's position so that they start in the same place where they leave off. In our game data script, we'll add a vector3 variable called player position, and then in the constructor, we'll just initialize this to vector3.0, but remember that these should correspond to the initial values you want for a new game. In this sample project, I have a player game object that has a character controller 2D script attached that would be a good spot to save and load the player's position. So we'll open up that script and then implement the iData persistence interface, and then we'll add the load data and save data methods. In load data, we'll set the transform.position of this game object to the data.playerPosition of our game data. And of course in save data, we'll do the opposite, setting the data.playerPosition equal to the position of this game object. And just like that, now we're saving the player's position. We can go back into play mode, move the player to a different spot in the scene, and then exit play mode so that the game saves. If we look at the data file, we'll see that we're now successfully saving the player's positional values, and of course if we go back into play mode, the player now starts in the same position as where we left off. The next thing we want to save are the coins that the player has collected. This is a bit more complicated than the previous things we've saved, so let's think about it for a second. We have a bunch of coins scattered throughout the level, and when we collect them, they disappear. When we save the game, we need to know specifically which coins we've collected so that when we load the game, we know exactly which coins to make disappear so they can't be collected again. We can do this by saving the data as a dictionary where the key is a string that represents a unique ID for each coin, and the value is a boolean on whether or not that coin has been collected. This concept works well not only for collectibles, but also works well for things like checkpoints, unlockables, and more. In our game data script, we'll add a dictionary of type string to boolean called coins collected, and then in the constructor, we'll just initialize this to an empty dictionary. Next, let's give each coin a unique ID. In this sample project, each coin game object has a coin script attached, which will be a good place to put the ID. At the top of that script, we'll add a serialize field private string ID. We could fill this out manually, but through researching some stuff for this tutorial, I actually found a really cool way of generating unique IDs automatically. We'll create a context menu option called generate GUID for ID, and then right underneath that, we'll create a private void method called generate GUID. In that method, we'll simply set our ID variable equal to system.GUID.newGUID.toString. Now back in the Unity inspector, we can right-click on our coin script and then select the generate GUID for ID option that we created, which will fill out the ID field for us. For those unfamiliar with GUIDs, they're essentially strings of 32 characters that have an extremely high probability of being unique. So we'll go through and generate these for each coin so that every coin has a unique ID. Next, back in the coin script, we'll implement the iData persistence interface and add save data and load data methods as usual. For each coin, this script already has a boolean called collected that's keeping track of if the coin has been collected or not, so we can use that as the value to store in the dictionary. In load data, we'll call try_get_value on the coins collected dictionary using the ID to get whether or not this coin has been collected. And if it has been collected, all we need to do in this case is set the visual game object to be inactive so the coin can't be collected again. When we save the data, we'll check if the ID for this coin is already contained in the coins collected dictionary, and if it is, we'll remove it before trying to add it again. And when we add it, we'll add the ID as the key and then the collected boolean as the value. So that will take care of saving and loading the data for the coins themselves, but there's also this UI text that needs to be loaded. There's a script called coins collected text attached to the UI text that we can use to load this. In that script, there's a variable called coins collected, which is essentially what's getting displayed in the UI. So all we have to do here is implement the iDataPersistence interface as usual and also implement the save and load methods, but in this case we don't actually need to save anything. As for loading, we'll just loop through each key value pair in the dictionary and then increment coins collected for each value that's true, which in this case will put our coins collected variable at the correct amount. So you would think that this should work, but if we jump back into play mode, collect some coins, and then stop the game and look at our data, we'll see that the dictionary isn't being serialized and saved to our file at all. What's happening here is that the JSON utility class that we're using for serialization unfortunately doesn't support more complex data types like dictionaries. There's a couple of different things we could do to get around this. The first would be to use a different method of serializing our data. For JSON data, there's a third-party library called JSON.net that's free on the Unity Asset Store as of making this video, which I haven't used myself, but I have heard good things about. The second option is to use the serialization callback receiver interface, which we can use to put our dictionary into a format that can be saved by the JSON utility. In this tutorial, we're going to take the second approach. However, if you find yourself having to save a lot of complex data types in your game, then something like JSON.net could be worth checking out. Back in Unity, under the scripts data persistence folder, we'll create a new folder called serializable types, and then in there we'll create a new C# script called serializable dictionary, and then we'll double click it to open it up. We can remove the placeholder methods and mono behavior, and then we'll also add system.serializable to the top of the class. Then we'll add a generic key and value to the class name like so, and we'll also extend from the standard dictionary class so that we inherit all of the capabilities of a standard C# dictionary. And then we'll also implement an interface called iSerialization callback receiver, and with that is going to come two methods, onBeforeSerialize and onAfterDeserialize. As you probably guessed, these methods will get called right before serializing and right after deserializing, which means we can add translations in each of these to go to and from the dictionary type. Next, we'll add two serialize field private lists, one for keys and another for values, and we'll initialize them to new empty lists. In the onBeforeSerialize method, we'll make sure that these lists are cleared, and then we'll loop through each key value pair in this dictionary and then add those to the lists. In the onAfterDeserialize method, we'll first make sure that the dictionary is cleared. Then we can simply loop through and add each key value pair to the dictionary. And just for good measure, we can add a defensive programming check here to ensure that the key and value lists are the same size, since if they aren't, then something went horribly wrong and we should let ourselves know. And finally, back in our game data class, all we need to do is switch out the dictionary for the serializable dictionary class that we just created. Now, if we play this again and collect some coins and then exit play mode and look at our data, we'll see that these two lists are now getting saved to the file as expected. And of course, if we enter play mode again, we'll see that the data was loaded successfully and that the coins we collected were persisted. So that pretty much does it for saving all of the data that we wanted to, but you'll notice that because we're saving data in a readable JSON format, it would be really easy for the player to open up this file and then modify the game's data, which might not be desired. If you've done a Google search on this, or you've seen another tutorial on creating a save and load system, it's likely you've come across something called a binary formatter, which we could use to save the data as binary instead of JSON. While this would work, it's actually highly recommended by Microsoft to not use the binary formatter, and if you are using it, to switch to an alternative. So for this tutorial, we're actually going to encrypt our data using a simple encryption implementation called XOR encryption, which I know might sound like a scary thing, but I promise that it's actually going to be really easy. I'm not going to dive very deep into the details of how XOR encryption works, but essentially we're taking each character of our JSON data and doing an XOR operation against another character to flip that character into a different one. Because of how XOR operations work, we can do the exact same thing to decrypt the data back to the original characters. For that reason, we'll want to keep track of the characters we're encrypting the data with so that we can decrypt it in the same way. And for that, we'll create a string which will act as our encryption code word. We'll essentially pick characters from that code word to encrypt and decrypt against, which means that the only way to decrypt the data will be to know both the code word and the encryption algorithm being used. But just to be clear, this type of encryption, or any type of encryption that's handled completely on the client side, can be broken somewhat easily, since your code word and the algorithm would be stored on the client side in some fashion. With that said, the encryption we're going to do will make it quite a bit tougher to alter the game's data, and will likely prevent your average user from doing so. With all of that said, let's actually implement this. In the file data handler, we'll add a Boolean variable called useEncryption and set it to false. We'll also create a private read-only string called encryption code word. You can make this whatever you want, but I'm just going to use the string word. Then in the constructor, we'll take in another parameter for whether or not we should use encryption and then set that accordingly. And then at the very bottom of this class, we'll create a private method called encryptDecrypt that will take in some string data and then return a string of the encrypted or decrypted data. In that method, we'll loop through the entire data string, and for each character, we'll do an XOR operation between the original data and an index in the encryption code word. And then after that, we'll simply return the encrypted or decrypted data. Now in the save method, if we're configured to use encryption, we'll encrypt the data before we write it to the file, and then we'll do the same thing in the load method, but decrypt it after we've read it from the file. Next, in the data persistence manager script, we'll add a serialize field boolean for whether or not to use encryption, and then we'll make sure to pass that into our file data handler when we create it in the start method. Since we're switching formats, we should delete the data file on our computer so that we're starting from a clean slate. And back in Unity, we'll check this box to use encryption on our data persistence manager script. And now if we play this and then do some stuff and stop play mode and then go look at that file, we'll see that the data is encrypted and no longer easily readable or editable. And of course, if we start up the game again, the game loads based on our saved data just like before. And that's it. Thank you so much for watching. If you liked the video, please give it a thumbs up so more people see it, and if you want to see more from me, go ahead and hit the subscribe button as well. I've got a couple of ideas for other tutorials that might branch off of this one, so if there's something more you want to see out of a save and load system, feel free to put a comment below. Or you could stop by my Discord server, which is a great place to ask me questions, suggest a video topic, or just show off the game that you're creating. You can also follow me on Twitter or Instagram, where I mostly post about the game that I'm creating. Anyways, thanks again for watching, and most of all, I hope this was helpful.